Good evening, one and all present. I welcome you all to Ganesh IAS Academy. In today's session, we'll be seeing science and technology based current affairs. Let us get into the news articles one by one. And in this particular session, we'll be giving more focus to the Nobel Prize winners, okay, for biology, chemistry, and physics, okay. So these three things we'll be covering in detail. The first news is Nobel Prize in Medicine and Physiology. Okay, so who has received this prize? What is its significance? And for what invention or discovery? Let us understand that. So the Nobel Prize in Medicine or Physiology for 2023 has been awarded to Kathleen Carrico and Drew Weissman. For what? For their groundbreaking work on nucleoside base modification. So they have done nucleoside base modification of what? Of messenger RNA, shortly called as mRNA. So we need to understand in detail about what is mRNA and what is the role of mRNA vaccine. That we need to understand in detail, and how have they modified this nucleoside bases. And why did they modify nucleoside bases? All these details we must have to understand in detail. Okay. So the discoveries by the two Nobel laureates. Okay. This was critical for developing effective mRNA vaccine against COVID-19. Yes. Okay. So that is the reason they have been awarded this particular Nobel Prize. Okay. And this pandemic was there in early 2020. Okay, it started in early 2020. So this method was very useful in developing effective mRNA vaccine against COVID-19. Okay, so let us understand further more details. So we need to understand the challenge that they had and how did they face the challenge or address the challenge. Okay, so generally cells possess an inherent capability to detect foreign materials. This is there in every cells. Okay. And there are particular cells called as dendritic cells, okay, which play a critical role in immune system. So these dendritic cells play a very critical role in our immune system, and they have this ability to recognize in vitro transcribed mRNA. So this term we need to understand. What is in vitro transcribed mRNA? And this dendritic cells are going to recognize these in vitro transcribed mRNA as foreign, which means they are foreign material to these cells. Okay, which means they will be creating antibodies against these foreign materials, but then they are setting off an inflammatory response. Okay, generally in vaccines such inflammatory response are undesirable. Okay, so this reaction could potentially lead to harmful side effects and undermine the vaccine's efficacy. Okay, so when in vitro transcribed mRNA is going to be used for vaccine production, then these side effects like inflammatory responses could potentially be a threat to human beings. Okay. Furthermore, another challenge that stemmed from the fact that in vitro transcribed mRNA was highly unstable, one thing, and then they are also susceptible to degradation by enzymes. Okay. So they are highly unstable, they are susceptible to degradation by enzymes, and they are also causing inflammatory responses. These are the challenges that in vitro transcribed mRNA had, and how did they address this challenge? Let us understand that. Before that, let us understand in detail about this in vitro transcribed mRNA. What is it? In vitro means in lab. Okay, vitro means glass. Okay, so they are going to do this in test tubes. That is why it is called as in vitro. Okay. So in vitro transcribed mRNA is a type of synthetic RNA. So it is synthetic RNA which is produced in the laboratory. Okay. So a question based on this may be directly asked in your prelims examination. What is in vitro transcribed mRNA? Okay. So it is produced in laboratory by using DNA template and RNA polymerase. Okay. So generally RNA is produced from DNA, right? So it is produced by using a DNA template and RNA polymerase enzyme. Okay, and this in vitro transcribed mRNA can be used for various purposes like making RNA probes, vaccines, and also for production of protein. Okay, so these are the details which we need to understand with respect to in vitro transcribed mRNA. Furthermore, details that we have to know is the discovery made by these two scientists who won Nobel Prize. So, Carrico and Weissman observed that dendritic cells identify this in vitro transcribed mRNA as foreign, which we already saw, and activating them and causing release of inflammatory response, okay, inflammatory signals. And they questioned why this mRNA was considered foreign, why this in vitro transcribed mRNA is considered as foreign, whereas our mRNA from mammalian cells. In human beings, we have mammalian cells. In mammalian cells of mRNA, such response is not there. Okay, so which did not trigger the same response. Okay, so why is there this distinction between mammalian mRNA and this in vitro transcribed mRNA? They were researching this. And mammalian cells, what are mammalian cells? Let us understand that also. Mammalian cells are eukaryotic cells. Okay, we all are eukaryotic organisms. Okay, so eukaryotic cells that belong to animal kingdom and have a nucleus. Eukaryotic means it will be having a well-defined nucleus and other membrane-bound organelles. That is the meaning of eukaryotic, which is the opposite of prokaryotic, which will not be having a well-defined nucleus and membrane-bound organelles. Okay. Next, this led them to realize that there must be a distinct property separating the two mRNA types. So, what is the distinct property that we need to know? So, what was the breakthrough? RNA, like DNA, consists of 4 bases. We all know adenine, guanine, uracil and cytosine. Okay, in DNA the 4 bases are adenine, guanine, thymine and cytosine. Okay, whereas in RNA it is adenine, uracil, guanine and cytosine. Okay, here these two scientists have noticed that the natural RNA from mammalian cells often had chemical modifications in its bases. It is just because of these chemical modifications they were not giving such inflammatory responses. Okay, so that is what they have found, that is their finding. Okay, so they have hypothesized that absence of these modification in lab made mRNA, that is in vitro transcribed mRNA, might cause inflammatory reactions. So the point that we must have to note here is these mRNA, that is lab made mRNA or in vitro transcribed mRNA, having absence of these modifications in bases. What are the bases? Adenine, uracil, guanine and cytosine. Okay, and to test this they created various mRNA variants with unique chemical alterations and delivered them to the dendritic cells which were showing the inflammatory response. Okay, and their results showed a significant reduction in inflammatory response when base modifications were included in mRNA. So for this nucleoside base modification only they have been awarded Nobel Prize. Okay, so this we need to know. Next is this discovery transformed our understanding of how cells recognize and respond to different types of mRNA, with profound implication for mRNA's therapeutic potential, that is its potential as a vaccine. Okay, and their subsequent studies in 2008 and 2010 demonstrated that mRNA with base modification led to increased protein production. This is also there. Okay, so these two scientists have researched, their research removed the critical obstacle. What was the obstacle that we had? That these mRNA were producing inflammatory response. Okay, and making mRNA more suitable for clinical application. So this is the background which we need to understand. Next is mRNA vaccine and their working. How does mRNA vaccine will work? This we need to understand from exam point of view, from prelims and mains point of view. Okay, so how does mRNA vaccine work? mRNA stands for messenger RNA, we already know, but what is messenger RNA? It is a molecule that carries genetic information from DNA to the protein making machinery of the cell. So it is like a messenger, it carries genetic information. Okay, it is sending the information from DNA to the protein making machinery. Okay, So mRNA vaccines use synthetic mRNA that encodes a specific protein from a pathogen. So in case of this coronavirus, here the protein is spike protein. In coronavirus, you would have noticed that it will be having spike protein. Just because of the spike, it is called as corona. This shape is called as corona. This spike shape is called as corona. Okay. So these spike protein are encoded, and they will be, that message or that genetic information will be transferred to the cells. After it being transferred to the cells, when the mRNA vaccine is injected into the body, some of the cells will take up the mRNA and use it to produce protein. RNA's job is actually producing protein. Okay, so it will use it to produce this protein, this spike protein, and the protein then triggers. So a foreign agent has entered into the body. So whenever a foreign agent is going to enter our body, then there will be an immune response which produces antibodies and memory cells, and there will be memory cells that can recognize and figure that pathogen in the future. Okay, so this is how the mRNA vaccine works. Okay, so let us see that in the picture. mRNA coding for SARS-CoV-2 protein, spike protein. Okay, here it has been coded, the code is being injected. Okay, that mRNA, the messenger RNA, is being injected. Here the mRNA released into the cells where it is used to produce spike protein. Okay, these spike proteins are going to be produced inside our body, and to that our body will be producing antibodies. Okay, so creation of antibodies that can recognize this virus. So once antibody is created, it will go and it will go and defend this spike protein, and that memory will be stored in our immune system. Okay, so after that, whenever the spike protein is encountered by our body, then automatically our immune system will react to it. Okay, so this is how it works. This vaccine works, mRNA vaccine. Next, so for this particular topic, for this particular finding, these two scientists have got Nobel Prize for biology and physiology. Okay, so the next topic, let us discuss. The topic that we are going to discuss now is Nobel Prize for Physics 2023. Okay, so let us understand who has received this Nobel Prize and for what. Okay, so 2023 Nobel Prize for Physics has been awarded to 3 scientists. Who are they? Pierre Agostini, Ferenc Krauss, and Anne Lullier. Okay, so these are the 3 scientists who have been awarded Nobel Prize. And for what? For their groundbreaking work in the field of experimental physics. So they have been working in the field of experimental physics and has led to the development of something called as attosecond pulses. So we need to understand in detail about what is attosecond and what are attosecond pulses. Okay, enabling the scientist to directly observe and study the rapid dynamics of electrons within matter. Okay, so we can study the rapid dynamics of electron using these attosecond pulses. So we need to understand the dynamics of electron first. Okay, the electron dynamics. So that is what our next thing is. So electron dynamics. What are electrons and what are electron dynamics? Electron dynamics refers to the study of understanding of the behavior and motion of electrons. So understanding the behavior as well as motion of electrons within molecules, atoms, and even solid materials. This is called as electron dynamics, and this study of electron dynamics encompasses various aspects of electron behavior, which includes their movement, their interaction with electromagnetic fields, and also their responses to external forces. All these will be studied under electron dynamics. And what are electrons? Electrons are actually fundamental particles with negative charge. We already know this. We write it like this, right? Electron, E minus, which means negatively charged. So they are fundamental particle with negative charge, and they orbit the dense nucleus. So there will be dense nucleus. Inside nucleus, you will be having neutrons and protons, and these electrons will be revolving around this nucleus. Okay, They will be orbiting. So for long time, scientists had to rely on indirect method to understand the electron behavior. So to which they are comparing this? They are comparing this to taking a photograph of a fast moving race car with a long exposure time resulting in a blurry image. Obviously, when we take photograph of a fast moving race car with a long exposure time, then we will be getting a blurry image. This is how they have been recording the movement of electron. Okay, but then now we have got a new technology or a new finding with which we can image the electron movement very precisely. Okay, so that is what the finding is. So the rapid motion of electron rendered them nearly invisible to conventional measurement techniques. We at present have conventional measurement techniques, to that these electron movements are invisible. And atoms and molecules exhibit movements in the order of femtoseconds, that is 10 power minus 15. Okay, so femtoseconds, which are incredibly short time intervals. Femtoseconds are itself incredibly short time intervals, that is a millionth of a billionth of a second, that is femto. Okay, but electrons being even lighter, interacting and even faster, they operate with attosecond realm. So atoms will be exhibiting movements in the order of femtoseconds, but electrons will be exhibiting movements in the order of attosecond. Okay, so what is an attosecond? A billionth of a second is called as attosecond. Okay, that is 10 power minus 18 of a second. Okay, next, an attosecond pulse is an incredibly brief burst of light. Very brief burst of light is called as attosecond, that lasts for attoseconds. Okay, so these are called as attosecond pulse. So this is what the finding is. For this is what those scientists have been awarded Nobel Prize. Okay, let us understand the applications of attosecond. So applications of attophysics, attosecond physics. First thing is studying short-lived processes. Okay, so attosecond pulses enable scientists to capture images of ultra-fast atomic and molecular processes. Okay, so there are certain processes which are ultra-fast in the scale of atomic scale and molecular scale. Okay, so to study them, these attosecond physics is important, and then this has a profound implication in the field of material science, electronics, catalysis, where understanding rapid change is crucial. So when there is going to be rapid change in the field of material science, electronics, or even catalysis, in catalysis there will be rapid change in dynamics. Okay, so how does that happen? We need to understand that. To understand that, we need something like attosecond. Okay, next is in medical diagnostics also we are using attosecond. We can use attosecond pulses. So attosecond pulse can be employed in medical diagnostics to detect specific molecule. Okay, for detection of specific molecule, and this promises improved medical imaging and diagnostic techniques in future. Okay, what other applications do we have? Advancing electronics. Yes, attosecond physics may lead to development of faster electronic devices, pushing the boundaries of computing and telecommunication technology. So for development of faster electronics also this might be useful. Next is enhanced imaging and spectroscopy. So the ability to manipulate attosecond pulses opens up possibility for higher resolution imaging and spectroscopy, which we already discussed. So for taking higher resolution imaging and spectroscopy, these attosecond pulse can be used, and they find application in the field ranging from biology to astronomy. So these are the details which we need to understand from this particular topic. So see how questions can be asked related to Nobel Prize topic. Okay, these were the previous year questions in UPSC. Who among the following scientists shared the Nobel Prize in Physics with his son? This was asked in 2008. Answer to this is William Henry Bragg. Okay, and Nobel Prize winning scientist James D. Watson is known for his work in which area? Okay, so such questions can be asked in your prelims examination directly. So the answer to this is genetics. Okay, James D. Watson was working on genetics. Okay, so you need to give importance to such topics, who were the winners and for what did they receive this Nobel Prize. All these things are important. Okay. The topic that we are going to discuss now is Nobel Prize in Chemistry 2023. Who have received Nobel Prize in Chemistry for 2023 and what is the significance of their finding and its applications? Let us understand. The Royal Swedish Academy of Sciences awarded Nobel Prize in Chemistry 2023 to Magni D. Bavandi, Louis E. Bruce and Alexei I. Ekimov. To these three scientists, they have awarded Nobel Prize. For what? For their groundbreaking discovery and synthesis of quantum dots. So they have found something called as quantum dots. So we need to understand what are quantum dots here. So let us get into the history of finding quantum dots. How did they arrive at finding quantum dots? So traditionally, all pieces of a pure element, regardless of its size, were believed to be, so they were believed to have identical properties due to uniform distribution of electron. So since material are going to have uniform distribution of electron, they thought that all pieces of pure element, regardless of their size, will be having identical properties. But this was proved wrong. How? However, about 40 years ago, scientists discovered that nanoparticles, when material are taken to their nano size, those are called as nanoparticles. Okay, so nanoparticles at nanoscale, typically 1 to 100 billionth of a meter in size, those material exhibited distinct behaviors which is different from their larger counterparts of the same element. Okay, say for example, we have gold in macro size. Okay, 1 centimeter gold or 1 meter gold, a big chunk of gold. When we also have gold in nano size, these two gold will be having different properties. So when we change the size, the properties are going to vary. That is nanoscience. Okay, so that is nanotechnology. Okay, so this challenged the conventional belief. Okay, so this only gave rise to the concept of quantum dots. How? Let us understand. So the factors responsible for distinctive properties of nanoparticles. First thing is, the conventional behavior of small nanoparticle is actually a result of the emergence of quantum effects. So when you take a material to nano size, they exhibit quantum effects. Okay, they undergo quantum effects. Next is, despite nanoparticles being considerably large than individual atoms. Okay, so atoms are actually measured in angstrom, right? Angstrom is 10 power minus 10 meter. That is angstrom, whereas 10 power minus 9 is nanometer. Okay, so nanoparticles are actually considerably larger than individual atoms. A crucial insight emerged in the year 1930s. In 1930s, when particles are reduced to nanoscale, quantum effects came into play. Okay, and this is primarily because under such conditions, when the particle are taken to nano size, this is important, this point is important. Electrons within atom find themselves confined within a limited space. Okay, this is the reason why they are exhibiting quantum effects at nano size. Okay, so the electrons within atom find themselves confined within limited space. Why are they finding themselves confined within limited states? That reason also let us know. Typically, electrons move within a relatively spacious area outside the nucleus of an atom. Okay, so consider this to be nucleus, and this, if this is an electron, these electrons will be moving like this. They are having a lot of space to move around a nucleus. But as particle size drastically decreases, electron experiences increasing constraints. Okay, when there is a reduction in the size of the particle, then they are going to experience increase constraints, okay, and this led them to the manifestation of these peculiar quantum effects. Okay, so electrons are facing constraints. That is why quantum effects are emerging. Next, this profound understanding are observed and demonstrated by Nobel laureates Ekimov and Bruce in their laboratories and resulted in the creation of nano-sized particles with distinct behavior compared to their large counterparts of the same element. Okay, like we already discussed, and these remarkable nanoparticles which possess unique properties came to be known as quantum dots. So these nanoparticles are quantum dots, okay, which we need to understand. Next is, what are the features of quantum dots? First thing is, quantum dots are nanoscale particles which we already know, and they are of typical size which ranges from 1 to 100 nanometer. Okay, when they say nanoparticle, it means their size is from 1 to 100 nanometer. That is nanoparticle. Okay, this has to be in our information. Okay, then these minuscule structures possess unique properties that are governed by their size, and this point is important. The second point, notably the size of the quantum dots determine the color of the light they exhibit. Okay, see here, with smaller dots emitting blue light and larger ones shining yellow or red. So smaller dots will be shining blue lights and the larger ones will be shining yellow and red color lights. So all these are having nanoparticles of the same element. Okay, all these are having same element, but then they have differently sized quantum dots. Okay, when the size is larger, when the size is smaller, then they emit blue and green color. When the size becomes bigger, they emit yellow and red color. Okay, so this we need to understand. This is a technical point. Next is, what is quantum effects and what is quantum technology? We already studied what quantum effects is and what is the reason for quantum effects. Let us understand that. Quantum effects refers to the fundamental behavior of a matter and energy at the smallest scale. That is called as quantum effects, where classical physics no longer applies. This is important. Okay, we actually have classical physics, right? Physics that we study in our classes. Okay, so those laws and those rules will not be applicable for these quantum effects. Okay, these quantum sizes. Okay, next is, quantum effects are the phenomenon that occur at the quantum level. We already know that is the nano level. Okay, where particles like electrons exhibit behaviors such as superposition and entanglement. Okay, I have discussed in detail about these two topics and various other terms related to quantum computing. Okay, so superposition and entanglement have already been discussed. Please go and watch it, and which are distinct from classical physics. These superposition and entanglement are very new to classical physics. Okay, next is quantum technology. Quantum technology means which harnesses unique properties of quantum mechanics to create innovative tools and applications. Obviously, technology means there will be creation of innovative tools and applications, including quantum computing, quantum cryptography, and quantum sensors with potential to revolutionize various fields in future. Okay, so this is quantum technology. Next is, what are the applications of quantum dots that have been discovered by these scientists? First thing is display technology. Okay, quantum dots can enhance the quality of displays such as LED lamps and television screens by emitting clear and vibrant light. Okay, this is one application. Next is medical imaging. They can be used in medical imaging. So they can eliminate tumor tissues during surgery. So when tumor tissue are eliminated, then they will aid the surgeon in precise removal of those tumor tissues. Okay, so this is how quantum dots are going to help in medical imaging, and their nanosized size, the nanoscale size makes them ideal for tiny sensors to be used as tiny sensors. They can be used as tiny sensors. Next is they are used for flexible electronics. Okay, they find application in flexible electronics. That is, quantum dots hold promise for flexible electronics, paving way for innovative and adaptable devices. Okay, which may come up in future. Next is slimmer solar cells. These quantum dots could lead to more efficient and compact solar cells, improving renewable energy solutions. Solar energy is a renewable energy. Next is encrypted quantum communication. For this also, these quantum dots can be used. Quantum dots might play a role in developing secure quantum communication technologies, protecting sensitive information. So these are the applications of quantum dots, and here again in this picture, applications of quantum dots are mentioned. Okay, so yes. So with this, we have discussed about the 3 Nobel Prize, that is for physics, for chemistry and for biology. You need to remember who has received it and for what. I mean, for what finding they have received it and what are the applications of the finding. Those 3 things you need to understand from exam point of view. Okay, so let us get into further more details. I mean, other news. The topic that we are going to discuss now is R21/Matrix M, which is a malaria vaccine. So what is so special about this vaccine? Why is it in the news? Let us understand. R21/Matrix M malaria vaccine. Okay. So recently WHO, that is World Health Organization, has recommended the use of R21/Matrix M malaria vaccine, which was co-developed by University of Oxford along with Serum Institute of India. Okay. Next is, what is Matrix M component? We are saying R21/Matrix M, right? So what is this Matrix M? It is a component. Actually, it is a saponin based adjuvant. So we need to understand what adjuvant is. Let us understand that in the next slide. And this saponin based adjuvant was developed by Novavax and licensed to Serum Institute for their use in endemic countries. Okay, so at present the vaccine has been licensed for use in Ghana, Nigeria and Burkina Faso. Okay, so let us understand what adjuvant is. This Matrix M component is actually a saponin based adjuvant. So we need to understand what saponin is and what adjuvant is. An adjuvant is an ingredient in vaccine that enhances the immune system's response to that vaccine. Okay, so it enhances the immune system's response to vaccine. And adjuvants help the immune system to better recognize what's in the vaccine and remember it longer. Thus, it will increase the amount of time the vaccine may offer protection. So this is the characteristic or the feature of an adjuvant. Next is, we already saw saponin, right? So this Matrix M adjuvant is derived from saponin, which is a naturally occurring compound found in the bark of Quillaja saponaria tree in Chile. Okay, and these saponins have a history of medicinal use. So that is why they are using this as an adjuvant here. Okay, what is an adjuvant? That ingredient which will enhance the immune response. Okay, immune system's response. And what are all the vaccines that we have for malaria at present? At present, recently, we saw that Matrix M vaccine is there, and previously, WHO has also recommended broad use of RTS-SAS01. Okay, this is again a malaria vaccine which was recommended to be used among children living in regions with moderate to high infection or transmission of malaria, that is Plasmodium falciparum. Next is, what are all the global elimination strategies that we have at present? Okay, so WHO Global Technical Strategy for Malaria 2016-2030, which was updated in 2021, it sets ambitious but achievable global targets, which includes These points are very important from exam point of view. First thing is reducing malaria case incidence by at least 90% by 2030, reducing malaria mortality rates by at least 90% by 2030. Next is eliminating malaria in at least 35 countries by the same year 2030, and preventing a resurgence of malaria in all countries that are malaria free. Okay, so all these are ambitious, but they are achievable global targets. Okay, WHO has given these targets. So this is it we need to understand about malaria and its vaccine. The next topic is the topic that we are going to discuss now is cookies. What are cookies in web world or internet world? Let us understand that, and what are all the uses of cookies and why is cookies a problem now? Those things we need to understand. As the ever evolving digital landscape continues to reshape online experiences, yes, we are experiencing that, cookies emerge as dual agents. Why are they called dual agents? Because they are serving as indispensable facilitators of personalization and convenience. Yes, this is the positive side, but they are also posing significant challenge in the domains of user privacy and data security. Okay, so that is why it is in news now. Okay, so these cookies, they are posing significant challenge in the domain of user privacy and data security. How? Let us understand what are cookies first, and then let us get into the details of its uses and its threats. Okay, so in the realm of computing and web browsing, what are cookies? Cookies are small pieces of data stored in user's device. So if there is going to be a user who is using internet, then these cookies will be stored as small pieces of data. Okay, and they will be stored as text file. Okay, points like these are important. They will be stored as text files. Okay, next is these files are actually generated by the website itself. Okay, so these files are generated by the website a user visits, and then serve the purpose of retaining information regarding the user's interaction. This is what important is. Okay, so what are cookies created for? These cookies will be retaining information regarding the user's interaction and preferences during their online navigation. So when we make an online navigation from one thing to another, we search multiple things in online, right? So when we make a navigation from one thing to another, when we search different things, then all the information will be stored. Okay, so all these interactions and the preferences that we make during online navigation will be stored as text files. Small piece of data will be stored. Those are called as cookies. Okay, now let us understand what is the role of a cookie. Okay, first is user authentication. That is its first application or the first role, that is functioning as digital identity card. Okay, so these cookies function as digital identity card, and they assist websites in recognizing and preserving user login status throughout their visits. Okay, this we might have noticed. Okay, we'll be asked to check a box so that the login ID and password will be saved forever. So that information will be saved as a cookie. Okay, so that is digital. It is like a digital identity card. Next is personalization. Cookies enable retention of user preferences encompassing language selection and website themes. Okay, when we open a particular website and if we choose language and website theme, and the next time we visit the same website, the same language and the theme will be already there for us. Okay, when we log in through our account. Okay, so such information are stored in cookies. Okay, next is persistent shopping carts. So they ensure that the items added to the online shopping carts remain accessible even upon subsequent returns. This is yet another role played by cookies. When we shop online, we'll be choosing items to be added to the cart. Okay, and even if we visit after a year, the items added to the cart will be shown. Okay, that is because of the information stored in the form of cookies. What other role or application does it have? Analytics. Okay, so cookies aid website proprietors in collection of valuable data concerning user interactions. Okay, thereby facilitating enhancement and tailored content delivery. This is for the website proprietors. Next is targeted advertising. This is also yet another application or the role of cookies, that is advertisers employ cookies to showcase advertisements that corresponds to the user interest. This we might have noticed. We might have searched for a particular thing in one website and an ad regarding that same item or the same thing will be shown in another website that we open. Okay, that is because of cookies again. Okay, so it corresponds with the user's interest and previous browsing histories, enhancing the allure of online shopping. So it will attract us by showing those advertisements. So these are the roles played by cookies. But what are all the associated challenges with cookies? That is privacy concern, like we discussed in the first slide. That is, cookies possess the capability to track online behavior. So it has this capability to track online behavior, and it raises concern about potential intrusion into digital privacy. Okay. Next, if it is not adequately secured, if the cookies are not adequately secured, then it can serve as vulnerabilities which can be exploited by cyber criminals to gain access to and also steal personal information. This might also happen. So cookies has to be secured adequately, but there are chances that it may be inadequately secured. Next is through cross-site request forgery. Okay, cross-site request forgery. Attackers can use cookies to perform unauthorized action on a user's behalf without their consent. This might also happen. So these are the negative sides of cookies. What other things do we have? We have something called as cookie bloat. Okay, so what is cookie bloat? Cookie bloating means what? Over time, as users visit more websites, cookies accumulate on their device. Okay, this information will be stored in their device only, right? So they accumulate on their device, consuming storage space. So when they consume a lot of storage space in a particular device, then that situation is called as cookie blot, and this potentially slows down the web browsing. Okay. Next is impact on user experience. How? User may find these frequent consent requests. Okay, will be getting pop-up messages for consent, right? Like, do you agree to it? Shall we sign in? Such pop-ups will be coming frequently, and this is annoying and disruptive to the browsing experience of people. Okay, as they have to interact with these dialogues repeatedly. These are also done by these cookies only. Okay, so these are the negative sides of cookies, and we also discussed about the role or the uses of cookies. Okay, so these details we need to understand about cookies. So with this, we have come to end of this particular session. I hope you found the session to be very useful and informative. Let us see in the next session. Thank you.